Hello students, today right now we are going to look at another topic which is the initial and final and final conditions of circuit element. Initial and final conditions of circuit elements. See, what is happening here is you have all studied that we are having capacitance, inductance, resistance as circuit elements. So I am having resistance here, I am having inductance here, and I am having capacitance here. Okay. Now we have seen in the previous class what will happen when we try to transform the circuit RLC components in the frequency domain. We have seen that the resistance will remain unchanged, whereas the inductance will have a value L being changed to Ls. In this circuit it will change to Ls, and if it is a parallel circuit, then we will have again Ls, and if there is some if there is some initial charge in the inductor, then that will reflect as either a voltage source in this circuit or as a current source in the parallel circuit. Same way we have also seen that in the case of a capacitor, if there is initial voltage, some voltage to which the the capacitance is charged, then that stored voltage will appear as this, and thus in the parallel circuit it will appear as a current source having this value. Now here what has happened to C is getting changed to 1 by Cs. So what we can say is, when we go from time domain to frequency domain, one thing that is very sure is that the capacitor goes from C to 1 by Cs, and L becomes, from L it goes to Ls, and R remains as such like R itself. So R remains R, L becomes Ls, and C becomes 1 by Cs. That we should never forget. Now when we are coming for the initial and final condition of the circuit element, what is the need for this? See, when you are having a capacitor and you are trying to charge a capacitor, or when you are connecting some voltage source to a capacitor, the capacitor will slowly start charging. So if I am going to draw the voltage with time, this is time and this is voltage, then initially the charge will start filling up and the voltage will slowly start developing in the capacitor, and it will develop and it will saturate at a point, and we will say that it has charged to some value Vc. Okay. Similarly, the inductor also, if suppose we are trying to pass current through it, initially the current will be 0, and then slowly it will start rising, and then only it will finally completely flow through in the inductor. So this change in all these elements, in both these elements, basically make us think that what will happen when some voltage is started to flow, or some current is started to flow through the capacitor, or some current is started to flow through inductance. What will happen? So we are having the initial and the final conditions. The initial state being that we are talking about, for the initial it means that we are talking about the time t is equal to 0 plus. That means 0 plus means just after 0. And final time we are talking about when we have waited for sufficient duration of time, which we will take it as infinity. Okay. Time infinity does not mean that we have to wait for infinite time. It means basically that we have to wait for a long time. So there are three changes that will happen, 3 time that will happen. Okay. One is at t is equal to 0, just before that and just after that what will happen to any circuit or any circuit element. Okay, what will happen to, so this is the time and this is t is equal to 0 and this is some t which is tending towards infinity. I am not saying that it is infinity, it is tending towards infinity, and this is the negative t or the negative time. Okay, now this is basically the initial stage and this is the final stage with respect to time, and there is some time in between where the change is occurring, either the capacitor is charging or the inductor is charging, or it may be even discharging. Okay, it is based on circuit, it may be charging or it may be discharging. So there is an initial stage and then there is a final stage. Okay, so if we talk about an uncharged capacitor, if we talk about an uncharged capacitor, then what we will find is that at t is equal to 0 minus at t is equal to 0 minus, that is just before the initial condition, we will consider that a capacitor is just like a capacitor and it is uncharged. Okay, that is the main thing, it is uncharged. Charged means it is having voltage, uncharged means it is not storing any voltage, because the capacitor can store voltage, so it is called charge. So if it is uncharged, then at t0 plus, at t0, t is equal to 0 plus, that means at the initial condition, if we are trying to flow some current through it, the current will totally flow through the capacitance. It will straight away flow through the capacitance, which will make us think as if there is no capacitance and this is a short circuit. So initial condition, so the initial condition of a capacitor when it is uncharged and some current is passed through it is that it will act as a short circuit. And once it starts charging, slowly it will charge, and as it is charging it will start opposing the current. Okay, now it is going through this stage which is called as the transient stage. Transient stage. What is the meaning of transient? Transient means changing, something that is changing. So the capacitor is changing, it is going through a transient stage, and during the transient stage, when it is uncharged, it will slowly keep on charging. Okay, to slowly keep on charging, and at t is equal to infinity, once the capacitor is totally charged, what we will find out is that it is accepting no more charge. That means it is not allowing any more current to pass through it. Here there was current passing through, here there is no current, so I is equal to 0, it is not allowing any current. That means it is as good as a open circuit. It's as good as an open circuit. So this is the final condition, this is the final condition of the capacitor. This is the final condition of the capacitor. Now, so this was when we were talking about uncharged capacitor. Similarly, if we are going to look into the case of a inductor, so if we talk about uncharged inductor, if we are talking about an uncharged inductor, then at t0, at t is equal to 0 minus, what we will have is a normal inductor. Okay, and it is uncharged. Again, it is uncharged. What do you mean by charging of a inductor? The inductor, when current passes through it, it will charge by storing the energy as magnetic energy. Here it is storing itself as electrostatic energy, electrostatic energy, that is saving up on charges, whereas here it charges up magnetically. It's magnetic charging. So what happens? The magnet inside the inductor gets slowly charged up. That means the magnet gets some power, and once it gets the power, that magnet is released, because of which the current is not anymore allowed to pass through the capacitance. So if that is the case, that means initially it is uncharged, then at t is equal to 0 plus, the inductor, if you would try to pass current through it, initially it will oppose. That is the nature of the inductor. Initially it will oppose any change in current. Okay, so initial condition is this statement you have to very carefully remember. It will oppose any sudden change in current flow. So it will not allow, even if you change the voltage, across the inductor, if you change the voltage, it will not allow that much current suddenly to pass through it, because the inductor is having that characteristics that it does not allow sudden change in current flow. So when there is an inductor and you have applied and you try to pass some current through it, it will not allow that change, because of which it will act as a open circuit initially. And once it has charged, what will happen? It will allow the current to pass through it. So at t is equal to 0, at t is equal to infinity, what happens is, it will allow the the current to pass through, so it will appear as a short circuit, and it will allow the current to pass through, and this is the final condition. So the time period in between is the transient stage of the circuit element. So what happens is, there will be an initial state of the circuit, and then at t is equal to 0, that means at some time a change will occur. Most probably a change will occur with the help of a switch. So some switch in the circuit, there might be switch. You all know what is a switch. A switch is basically something that can make a circuit open circuit or closed circuit. If you would close this switch, then it will become short circuit. So a switch somewhere will bring a change, or it will start a change. So before that switch is switched, what we are having is the initial state of the circuit. And then after the initial stage, it's the transient state or the transient stage wherein the circuit is going through the change. The inductor and the capacitor are either charging or they are discharging. And then finally, at some t is equal to t tending towards infinity, or at some time period, it will saturate. What will saturate? Saturation means it will fill up. What will fill up? Either the capacitor or the inductor will get totally, it will get totally charged. And then we will have a different scenario of the circuit. So you can imagine, that, again let me draw the timeline. So if this is the timeline, suppose this is the timeline, and we are having 3 sections. The first section is the time before this change is made. So here we will consider the circuit to be initial stage or initial state of the circuit. So that I will write, and then okay, let me write it. So here it is the initial stage of the circuit. Initial state of circuit. So what will be the initial state? Here the initial state will be that the resistance will remain as a resistance, the capacitance will be as a capacitance, and the inductor will remain as an inductor. And then at t is equal to 0, you are making a switch, or you are switching. You apply a switch. Once you apply a switch, so all of a sudden the circuit is now in an initial condition, and that initial condition is that all the capacitance, if it is uncharged, the capacitance will become short circuit. This is what is going to happen to a capacitance. What will happen to an inductor is, it will become open circuit. Okay. And what will happen to a resistance? The resistance will remain as such, no change. Okay. If it is uncharged. Now, if after some time, once it is, the saturation has achieved, saturation is when the charging or discharging has taken place. So this will occur at some t greater than 0, I should write basically, but at some large value of t. Then we will say that what has happened to the inductor and capacitor in the circuit is that the capacitor will start acting like a open source if it has charged up completely, and if the inductor has charged up completely, it will start acting like a short circuit. And what will happen to the resistor? The resistor will remain as such. The resistor does not change. So this is for the case of uncharged. If it was charged, then the resistance is no change, we know. If it was charged initially, then at that time the capacitor will be functioning as a open circuit, and here it will work as a, if it is charged, then it will work as a short circuit. Okay, if it is charged, it will work as a short circuit. And at some saturation time, if it is same here also, if it is This is for the case of uncharged. If it is charged, if it is charged, then what we will be having is the resistance will have no change. The capacitance, sorry, this was charged. This was charged and this is uncharged, sorry. So this was the charged state and this is the uncharged states. So in uncharged state, what we'll have is the capacitance will remain as short circuit and the inductor will remain as open circuit, sorry. Okay, so this is what will happen to C and this is what will happen to L. So what we can say is generally if it is uncharged, the capacitor is going to be short circuit, the inductor is going to be open circuit. That is the same case we have seen here. If it is getting charged, the capacitor will start acting as open circuit and the inductor will start acting as short circuit. Okay, if it is charged. And this we have to remember because what we are trying to do in this section is we are trying to write an equation of current and voltage in the transient stage, in the transient state or stage. Okay, so what happens in this transient state to the voltage and current in the circuit? What is the equation for that? That is what we are trying to find out here. So you should remember this final diagram that I have drawn. Okay.